Welcome back to another episode of Adventures in Machine Learning. I'm one of your hosts, Michael Burke, and I do data engineering and machine learning at Databricks. And I'm joined by my co-host,
Ben Wilson. I review design docs at Databricks.
and today we have a guest named Terry Rodriguez. Terry started his career in ML for robotics at Formant, and then he joined the machine learning team at Tubi, which is my old company, and their Fox's streaming service. And at Tubi, he focused on sort of content ranking and recommendation engines. He also created Smells Like ML, an innovation focused machine learning blog and consulting service. But most recently, he founded Remix AI, which is an automated machine learning infrastructure solution. So, before getting into the latest and greatest, what were you doing at Tubi?
Oh, at Tubi, I was working on their core recommender algorithms. And so a lot of the work that I was focused on was testing, experimenting with their ranking logic or their recallers that are used in the ranking in the recommender system. And a lot of that was also focused around like content embeddings. So I was working with some of the other teams in the way of developing text embeddings and image embeddings and other embeddings that we were deriving from the proprietary data they have so that we can try to find content similar to things people were really interested in watching and use that to recommend new content that we think that they would be interested in watching. So
Nice.
there's a lot of experimental workflows where you might come up with a hypothesis based on a previous experiment or based on some new technique you want to try. And we would come up with a hypothesis and test it offline and come up with a test that we wanted to change and use A/B testing to measure the effect of that.
Yeah, and to put a little bit more clarity about what this actually meant. So at Tubi, we had a data science team and then a machine learning team, and this split typically is not seen in other companies. But at Tubi, it meant that data science focused on decision science and inferential modeling. So we owned the A/B testing pipelines. We did a lot of causal analysis and sort of guided decisions. And then the ML team, they were at that time at least the cool kids, and they just like went deep into recommendation engines and figured out how on the home screen to organize content to maximize viewing. And so we never really sort of overlapped, but we definitely used each other's tools a lot. And it was a really interesting setup. The experimentation platform was awesome. That was one of my core projects.
Hey.
Just curious, what were your pain points with that platform, if you had any?
Oh, I mean, I guess I never found it to be too much of a challenge to work with that I can remember. I mean, making an experiment is hard, and you might think from an offline evaluation that your experiment's going to do really well, and oftentimes it doesn't. It's just a very difficult thing to do, but it was nice to have a framework that kind of made it easy to see when it's working, if you should pull the experiment. There was a lot of ways to customize the experiment so you could experiment more conservatively. I'm a big fan of what y'all developed there.
Awesome. That's good to hear because I have a massive list of complaints. So I'm glad it didn't exit the data science team.
I'm curious about the. Sorry to interject, Michael, but I've got nerd questions for Terry, specifically around embedded content to sort of hydrate poor quality data that's coming in. I lived and breathed that for a number of years at a previous company where you're getting third-party data, like you're selling somebody's stuff, whether it's media content in your case, or in my case, it was clothing and shoes and belts and stuff. They come from 15,000 different manufacturers around the world. Everybody has their own, I don't know if you could call it standards, but they were generating data. And some of it was acronyms everywhere, or some of it was internal like tool coding for patterns that they were using. The data wasn't consistent. And some manufacturers have human readable texts or machine readable text that you could extract from. I'm sure you saw something similar to that at Tubi when a new, maybe it's an independent film or something that's coming out, and you look at the data that's associated with that, and you're like, okay, that's one sentence of not really a sentence, maybe it's just a couple of tags. Can you explain how powerful it is in a recommender to add additional features to that in order to figure
Sure.
out that, like, hey, you might also like this?
Sure. Yeah. We would deal with proprietary data sets. Like Gracenote provides a lot of data about movie content, and as you said, you have these large content libraries. Tubi, in particular, that was a specialty of theirs. Is they have a very large library of video and series too. And so, especially when people are trying to decide like what content should they acquire, what's going to perform for our audience over there, it's very valuable to enrich whatever information you might have with the kind of structured information that you would get from Gracenote, and try to use that to address the cold start problem. It's like before you've seen the content's performance on the platform, you at best have a guess for how it's going to perform for your audience. And so if you can relate that content to content that is performing well, then you have a good hypothesis for why you might want to go acquire that title or how much you think it could be worth. And so we would bring in data like that. They would bring in data from all kinds of sources to learn more about their customers too. And so the more information that you can get about a person, things like their demographics or lifestyle can help you to identify patterns in viewership and find which content is going to resonate with your audience.
So one of the things that I've seen when highly ambitious young data scientists try to tackle this problem at a company, where it's like people think that if I throw all the data in, like everything that I could touch, and just put it into this one model, it'll magically just start recommending awesome stuff. Whether they're
Yeah.
using some hybrid approach with like old school ALS with, additional deep learning on top, or it's just pure deep learning implementation. Personally, I was always amazed at how bad those performed when
Mm.
you just start putting more and more information in.
Hmm.
Can you talk about how you approach a problem like that, or how
Sure.
you would design experiments around, like, should we include this exact raw data of like a continuous distribution of a lot of information within this one feature, or should we start quantizing this to make it more generalized?
Hmm. I know one thing that is interesting is a simple idea like alternating least squares was really effective at representing the content over at Tubi. So it was one of the more powerful features that we could use to retrieve similar content. But as you said, like just stuffing everything besides ALS, other content embeddings, other aggregate statistics that you might just kind of concatenate onto a giant data frame and then feed into, say, a deep learning algorithm. Recommender systems are often made with like simpler algorithms like XGBoost. And
Mhm.
so at the time that I was there, we were interested in exploring more with deep recommendation techniques like deep learning for recommender systems. But everything that I had seen up until the time that I was there was focused on using XGBoost for the ranking. And so we found that deep learning worked pretty well for content embeddings. And you can imagine like having this Gracenote data set I was talking about could tell you the year a title was released, the title, who's acting in it, just almost anything you would care about if you were scrolling IMDb's page to go learn about the title. And all of that could be kind of brought into a form that a deep learning model could ingest that, or you could subset parts of that rich data structure that I described and feed in like try to generate an embedding that's just based on something like a plot summary. And so we experimented a lot with different sources to create embeddings in, and testing them offline to see kind of intuitively, like if I were to use a text embedding that is trained on the plot summaries for a title, will I find, does this make sense intuitively? Will I find other titles similar to that if I use an embedding to try to recall like similar titles based on cosine similarity of the embeddings? See if that works intuitively. Then try using those titles that you were able to recall with that candidate generation step, and use that in the next step for ranking. So producing the final ranked results for the title. And if it passes that smell test, and if you can measure like improvement in the what is it? I almost forget now, the NDCG, the metric that we were interested in optimizing for our offline tests, then you're finally at a place where you have a case worth showing to the rest of the team, seeing if the rest of the team thinks that this is going to be a valuable change to the pipeline. And there's engineering trade-offs to make there too. It's not as simple as just throw it all at one model, and it's definitely not as simple as just pile in all the data, right? They could get a lot of different sources that would be harder to work with or might have a weaker signal. And so it was important for humans to be in the loop to try to make those determinations before possibly, leading to a bad user experience for millions of people.
Yeah, I mean, I couldn't have said it better. I mean, that's exactly how all of the sophisticated in production systems that I've either worked with or co-developed with people or built myself, they're all like that. It's highly curated feature data that you're controlling and observing at every step of that pathway. And you make this in the parlance of LLMs nowadays, and people are talking about chain models, chain LLMs. And it's like, it's not new. Like, that's how production ML typically works, where it's you might have 4 embedding models that are all generating embeddings based on this massive text payload that's coming in. You want to standardize that and reduce the computational complexity of that feeds into a later stage, final model. With systems that we did with like fashion, we were doing the same thing with like text embedding after doing a lot of cleanup on the labels that are coming in and descriptions and stuff. But then we found that the actual text data that we got was only correct about 40% of the time. So the color would be wrong. Like, it comes in 4 colors, and the labels that they have in the text, somebody just, Command C, Command V from something last season. And it's like, they don't come in those pastel colors. Now this season, it's all like dominant primary colors. And you look at all the images that come up, and the images are correct because those are from like the warehouse where it's being sold from. And you're like, this isn't right. So find out like, we can't use any of that data because it's almost always wrong. So let's do let's build a simple, image classifier that detects colors, and not even use deep learning. It was just old school computer vision to get that stuff. But then when you want to do style similarity, we found that image embeddings, like, just generate the embedding at this, like, basically the shortest point after a pooling layer. So like, this is what this thing kind of looks like to the human eye as an estimate. And then doing cosine similarity distance measurements with that, it was such a powerful, strong signal for us. So yeah, like, deep learning was involved, but it wasn't like what some people do. They're like, well, I just have this one massive model that has 37,000 inputs. Let's fill it and see what happens, because you can never diagnose what goes wrong with that.
So it's much more of a designed pipeline to make that work. And as you said, getting closer to that raw ground truth data with the image is kind of where deep learning might shine.
Yeah, and to add one more argument for context awareness when you're building these models and going for simpler, with Tubi, things were displayed on a grid, and that poses like a trillion problems when you're validating a model and also when you're recommending content. Like, if you're going to have container level recommendation where like the first one is horror, the next one is comedy, that's a very different recommendation and or like paradigm than like Google search, which is just sequential and there's only one container. And even worse, when you're A/B testing this, if you're on a Roku or some connected TV, you have a remote where you start in the top left corner. So the propensity of users to get all the way to the right is pretty low. Like, are they really going to press right 7 times and then down 2 times and then over and then down? So like basically controlling for that effect and then 70 other things with how users interact with content. It's super important when you're thinking about ML in that space. And so throwing deep learning at it and calling it a Kaggle competition just will not work for these complex use cases.
Yeah, I saw a lot of people were making very valuable experiments to try to suss out that presentation bias, right? Like that, as you said, the propensity to just kind of get the content that's near the top left, and so really measuring these like really subtle changes in user behavior with those kind of effects in the mix is very difficult. Yes, so that's why I'm a fan of the platform, and I think y'all must have really thought it out or had people with a lot of experience building an A/B testing platform to do it. But it's a very difficult problem with how the user experience, how the UI affects that experiment.
Exactly.
Yeah, that was really eye-opening to me the first time that I worked on a system that interacted with the front end that users are going to be interacting with, and then running A/B tests, because before we understood what was happening, the team, we weren't really talking that much to the front end developers and the UX designers. We knew, like, hey, here's the data we're generating. Is this good for you to consume? Can you do stuff with this? They're like, yeah, let's change that element, and we need this in a slightly different structure. And we're like, sure thing. Let's make sure that the API is versioned and you're comfortable with this. And then we release it, and we're watching the test trends are hold out against our test group for the first initial release. Everything's working really well. We're seeing, sales going up and interaction going way up, and I'm looking at by position data of how the recommendations are displayed, because we had what you said, Michael. It was like genre effectively, and not every customer would even see the same carousels, because we were actually doing recommendations based on carousel and content within carousel. So that was all dynamic. Like, when you go to that site, everybody gets a different homepage, basically. But we were watching the data, and then all of a sudden we'd see this huge spike in activity. And if we don't know what's going on, we're like, man, we're really good at this. Our model's awesome. And then you get somebody saying like, hey, data science team, did our change, did it work really well? Can you look at the data? And I'm like, what change? We didn't release another version. They're like, no, we changed the layout. Like, oh, we should control for all of that. Like, let's make that an A/B test. And then we start getting feedback to realize, hang on, there's an interaction here between the display and the model itself. So they did some front end tweaks, and we're like, if we now do a test within 2 different versions of the algorithm to coincide with that, let's see if we can boost that even more. And we started finding interactions like that. Like, okay, this is way more complicated than we thought.
That story actually reminds me, like, you'll run into all kinds of effects, things that even aren't happening on your platform that can make it difficult to explain, like, what's going on. And I remember one time when I was there, that the Slack channels were lit up, like, what is going on? Like, there's just a spike of traffic right now. And people were trying to figure out if something was broken or what. And it's funny because I had just seen something, and social media is like, YouTube is down. So I'm like, YouTube's down. I think this is what it is. And sure enough, they were able to kind of like quantify that effect afterward. But like, it can be things in the UI. It can be something's broken. It can be something's broken on somebody else's platform that make it difficult to determine like, why is this performing the way it is right now. And I remember they were also ranking containers for individuals. So like you said, it was they would have like a pinned container, something that they were trying to test, but then the containers themselves, the genres, right, would be personalized to individuals too. So it's like so many different effects. Different teams are testing different things. They're testing for different platforms, like the Android team, the iOS team, people for Roku. So it's really impressive to be able to say anything with all of these moving parts, right?
No comment. But yeah, you're hinting at sort of controlling for interaction effects, and without getting too deep, it's really, 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 really hard. But it can be done.
Yeah, I mean, the thing that you have to worry about with that is your degrees of freedom. So
yeah,
as you start slicing your data, at a certain point, you're basically just p hacking, right? You're going down and you're saying like, well, if I get this subset of customers and then do an A/B test across them, it'll be more accurate. I can control for this. I'm going to do region, and I'm going to do age range, and I'm going to do gender, and then I'm going to do a concatenation of top 3 favorite genres or types of thing that people are into, not specific content, but like, hey, this person's sci-fi horror drama, or this person's documentary sci-fi, cartoon or something, and you create a cohort of them. I've gone down that path and wrote all the code to do all that and generate, an A/B test group for that. And then quickly backed away once I looked at the result of executing my code. So I'm like, okay, 30% of my groups have less than 5 people in it. Like there's no statistical significance to be gained from that. So it's all about that trade-off of like, how precise can I be based on my population to do sampling of?
I really liked working on experiments on things like content embeddings. It's like a more fundamental component of the stack, where some experiments were kind of moving down that path of like segmentation. And it's like, it just makes for a much more complex pipeline too. I mean, what we just said a moment ago, right? There is not just one model that you can use. And so how can you find that trade-off of, techniques that are going to give you a lot of leverage, and they aren't going to be brittle, and they aren't going to make the code way more complex?
Right. So Terry, what is Smells Like ML?
Smells Like ML is a GitHub handle first, and then after my partner Salma and I had been working on a lot of projects to teach ourselves about applied machine learning, AI. We started a blog. I guess it must have been around 2017, 2018. And this is like a place where we were featuring some of our learnings, some of our projects. And we kind of expanded out to viewing that as like an innovations lab or consultancy, when we could work with people on projects. But I would say it's mostly a personal or professional hacker brand for Salma and I, as we were like participating in hackathon contests and putting out blog content.
Nice. And do you have any memorable blogs or memorable topics that you thought were very interesting?
Like, because it's so top of mind nowadays with generative AI, I think some of my favorite projects were in that area. And we had been messing around with these like Do As I Do motion transfer videos, where you could make an image. You could take an image of yourself and transfer that likeness over to like a video of somebody dancing to make yourself look like you were doing that kind of stuff. And so we started with a fascination for that technique and learning more about generative AI, experimenting with GANs, and eventually getting into diffusion. And so I guess it must have been in 2021. It was before latent diffusion, but there was earlier diffusion models that weren't controllable by text. And we started experimenting with that to, of all things, generate movie posters. We had a large collection of movie posters that we had scraped. And so with a data set that was more complex than, say, faces or ImageNet and things like that, could we train a model from scratch to generate posters? And so that was kind of a favorite project of mine, because I think I had a chance to see like how powerful diffusion really was, how much greater capacity those models had for kind of capturing the distribution of a image data set. But other projects I really liked, one from maybe around that year too, now that I think about it, was putting a custom image classifier on an Arduino BLE Sense. So this is like a battery powered microcontroller. And just the fact that you could put a image classifier on that could run in real time. And in our case, we were creating a custom model that did something kind of interesting. I think something that people don't really think that you can do with image classification. For more detail, like the prototype that we were working on was something like smart irrigation. And so we were exploring the ability for an image classifier to infer if a plant was like dehydrated, if it was showing like droop. It's a common thing for plants to do when they are out of water to go limp. And so making a classifier that could see like that nuance between a plant that was like perky and not needing water versus one that was like showing signs of drought stress. That was an interesting project to kind of test like what could you do with microcontrollers, what could you do with image classifiers. So that was probably a favorite project too.
Nice. And it sounds like you're a big projects guy. Have you always been like this, or are you building this up to sort of improve your technical skill set? Why do you do this?
I would say it's more the latter there. Like for me, I'll read a paper or I'll check out a GitHub repo, but of course, like papers can cherry pick the results and kind of show you like the best sides of things. It's important to get your hands on the code base and like determine how it works for yourself. It's like maybe a technique works really well for benchmark data sets that researchers are using, but when you go to apply it to something that you care about, not so much. And so getting familiarity with different techniques that I was curious about, learning more about it, or trying to push the limits of what could be done by trying out these ideas. I think learning by doing is really important. And I earlier in my career, I would do things like Kaggle, where you kind of have the data set curated for you, but that's like a different kind of workflow, right? Like at the end of the Kaggle contest, people are really hacking to get like that marginal improvement, because at the end, it really is about something that tends to overfit to that performance metric. And so I wanted to use projects to explore more of the engineering considerations that go behind like a model choice. It's like, yeah, there's a great new model out there, but maybe it involves 3D convolution, and now you need like some expensive hardware, and running it in real time is no longer a possibility. And so it might be of theoretical interest, but of practical interest, not so much. So trying to ground our experience on what works practically for problems that we were interested in.
Did you ever build a physical prototype of a solution that involved ML, where you're like, this could be useful? Maybe I should try to get funding to have some manufacturing plant make this and sell it?
Well, on that smart irrigation center idea, we did get outreach from some people who were representing a fund that was backed by like big agricultural tech group, and they were interested in like developing that prototype, getting users and things like that. We had a project with it, but by the time that we had heard from this group, we were like, months or maybe a year past
Right.
actually working on it and trying to develop it out. But there were other projects that we worked on and kind of committed to standing up a website for, and like exploring people's interest in that, things that we had like applied to YC with or something. So earlier in our career, we were really focusing a lot on kind of embedded computer vision, IoT projects, things before there were like smart cams, before there were like AI chips. We would be just like trying to reduce the model as much as we could and run it on a like a Pi Zero, something with a very small form factor, something that was not battery powered. And of course, like since then, there's a whole bunch of hardware and SDKs that have emerged to like really advance that space. But we were exploring like some of those ideas too, and I guess like, we must have come to the conclusion at some point that hardware actually is hard. And so we were kind of like, exploring more of what we could do with our careers in organizations that were well resourced so that we could work on problems that we were interested in, without the need for all that upfront capital to get going. I guess, software is a lot easier now too. And with generative AI, we were really thinking like, here's a new opportunity to do something on our own as a startup, because a lot of barriers have come down. You don't need as much data or even as much compute to do some of the things that were impossible like 5 years ago.
Nice. I think that segues perfectly into Remix. What's Remix?
Well, at Remix, we've been working on an agent to guide the development and deployment of AI applications. And so, what that means for us right now is more of a focus on deep learning models, on data sources that traditionally required like humans to label or review. So we're interested in kind of pushing the limits of what's possible in automation. And code generation has come so far, content generation has come so far. We started looking at things like image generators, text generators, and thinking about how we could address some of these machine learning challenges. So when I was working at a robotics group, we were building a robot that we wanted to be able to deploy in different warehouses, not ones that we owned. So not ones where it was easier or cheaper for us to scan the space and understand the content inventory for that warehouse. They're trying to build a robot to help in micro fulfillment centers. So you could imagine a lot of variability in the scene where a warehouse might be deployed. And so at that time, I was really thinking a lot about how we would be able to simplify that process of understanding the environment. And I was thinking a lot about sim to real, and the image generators had gotten to a point where you could tell like that practically speaking, like as far as an image classifier, an object detector is concerned, the image is as good as real. And I mean that to say like you have a lot of control over the design of an image, and that you can, when you bring an image like that to the resolutions that are used, like 200 pixel wide image frames, the fine grained details that a person might pick up on are not really noticeable. So as people working in the content generation space were kind of chasing the nines on improving the quality, the realism of those images. We were looking at it and saying like, this is quite good. And really what we care about is improving the efficiency of generating images for image data sets. And, when you're making like an image classifier, there's I would say a fairly well understood kind of best practices. You're going to use transfer learning using a tried and true backbone that's been pre-trained on a large image data set. You're going to use certain practices in the model selection, and that should depend on the hardware too. Like if you are running, as we were saying earlier, you can't just pick the most accurate model, but like there's constraints like, will this model fit onto the device that I need to run it? Will it run fast enough? That can depend on the SDKs that are available for that hardware. Like an op might not be supported in the newest, latest, and greatest model. Something like transformers came to some of these like smart camera devices probably like a year after transformers were being deployed in servers. And so with all of these considerations, it's like a lot of potential hurdles for people when they're trying to deploy a custom image classifier detector. And these are important components to perception systems. I mean, now things are trending towards like multimodal models, but those models too are still quite big. They don't run in real time. You know, you can't find everything that you care about in like open vocabulary, open set detectors. So there's a lot of kind of the best practices and recipes that are picked up, and they're easy to kind of build a pipeline or a system around. And we wanted to make it a lot easier for people who are trying to deploy like these models on devices to run in real time and in perception and vision. Could be like robotics and IoT, AR and VR. But as we were working on that problem, let's say at the beginning of 2022, especially when we were kind of formally launching what we've done at Remix, of course, ChatGPT is making remarkable progress, and we're seeing the possibility of bringing like high-level chat interfaces to that workflow. So what we had started with was focused around computer vision, but we had seen that making LLMs is getting cheaper too. And that's like data efficient, parameter efficient techniques are getting better. And so we're thinking about how we can expand to include like text generation, text embeddings, and really like how we can help people bring that domain knowledge that it takes to pull a model off the shelf and make it do something useful. It's as I said, like most of these models, they're released, haven't been fine-tuned on some research benchmark data set. And so you could imagine a situation where you have a robot and it needs to avoid the ladder, but you go look through one of these data sets like ImageNet, and there's no ladders. And so, you know, what are you going to do? You need to use transfer learning. You need to fine tune the model so that it can recognize this concept that's really important to your setting, your warehouse. And so being able to make that workflow like kind of really smooth for people, whether it's the training, whether it's the conversions, you know, we want to work to make it easier to deploy the models, because training the models is really a small part of the ML application lifecycle. So we're thinking a lot about how we can take our experience building these kinds of systems and make like a very simplified user experience for people who want access to AI models, but maybe they don't have a bunch of experience with training deep learning models and linear algebra and things like that.
So is the intention eventually for Mix, which is your chatbot, for that to be able to say, like, in the scenario you just presented, hey Mix, the model that you built yesterday with this ID or something, my robot hit 7 boxes that were sitting out on the floor. Can you build a model that will prevent that, and it will autonomously go and generate training image data that would show, like, here's a dangerous condition, like based on images you took of your warehouse, I'm going to superimpose boxes in the middle of the floor and say, this is dangerous. And then the same image without a box saying this is safe. Is that the intention eventually, to get to a point where it would use, you know, image generation techniques to create a training set, then train the model and help you deploy it?
To at some level, yeah. Where it is right now, it would be more like I need to differentiate these categories of objects. And so if you were to pull a model off the shelf, it's probably been trained to identify, 20 or 1,000 objects that you maybe don't care about. And so just first closing that gap of off the shelf model versus the model that's going to work for your deployment is where we are now. And what we would like to do is be able to serve those continuous updates. We'd like to be able to help with solutions to monitor the performance of the models. And we would like to be able to use like real images of your warehouse and techniques to synthesize or superimpose like some of these obstacles. It might be less of a this is safe or not situation than just identifying the obstacle. And that could involve not just classifiers or detectors, but maybe we could help with your ability to improve a depth estimation model, or any number of like current state-of-the-art techniques. We want to make it easier for people to use the right workflows, access the right data. And so for now, we're using image retrieval and image generation to design these data sets for the user's purpose. And to the extent that we could, it would be great to do more with automation. It'd be great to do more with procedurally generated data, where we could create a 3D asset and put it in different poses and things like that. So we're really exploring like all of the techniques that are in the best practice, and trying to codify that and trying to find ways to just make it a bit easier to deal with the agent at the level of like I have a request, or to make like executive decisions about it, and let the pipelines, the tools that are used in the background do the rest. So the user experience is like chatting with the agent and then having their intent kind of parsed and mapped to a specific workflow that would make sense to use, that one of us would have designed for that application. And just constantly be pushing on the state of the art there. If multimodal models end up smaller and faster and more real time, we'll be there to help people build those. And in general, there's a lot of excitement around being able to go find that one model that does everything you care about. But in practice and engineering, I've never been in a place where they said like off the shelf model was good enough. We don't need it to be both faster and more accurate. So there's going to be like all the tricks that you could possibly pull with data augmentation, with training the model, testing it, optimizing hyperparameters to some extent. But deep learning is pretty robust too. Like there's a lot of consistency out of the models. If you're not looking for like state-of-the-art performance on differentiating 1,000 different object categories, in practice maybe there's a much smaller set of concepts that you need to identify and work with. And the other thing that we think a lot about too is like just generally trying to invest in techniques that are going to help with that cold start or that few shot problem. Like how can we help people who are data limited get started, and then start the data flywheel that will feed into model improvements. So that should surely involve like a better UI for humans to help cheaply say like this is a good example, that's a bad example, so that we can take advantage of their judgment. But we're not quite there yet. I think the next step for us is getting to the point where we're helping to deploy the models. And I'm thinking of my experience with Formant, a robotics company, before I joined Tubi. They had an interesting idea, but I guess like I wanted to go a different way with where they were going with the product. They had an agent that could be deployed on your robot, and it would monitor ROS messages that are being sent on the devices. And a big part of what they were trying to do is just get that data off of these ROS topics and back them up to the cloud. But for me, I was also interested in deploying models on the agent, like helping roboticists run those types of models, helping simplify like their perception problems. And so I think a lot about that deployment model of being able to have like a lightweight binary that you can install. It's configured to point to a source. Maybe it's like, your device where the camera's at. Maybe it's a ROS topic, or maybe it's a directory of images. Maybe it's your data lake. But how can you deploy an agent so that it's just configured with all the information it needs to ingest from the input, and then produce that stream of detections or classification, whatever it is, like the structured information from the image sources, making that really easy so that someone has like a very simple high level CLI for, I need a model that does this. Now I need to deploy it. Here's the basic information I need about where the data is to consume and where to send it. Maybe we're helping people back up data to the cloud so that we can use the cloud resources to update models. We can run more powerful models in the cloud so that we have some way of measuring what's happening down on the edge with these, smaller, perhaps less accurate models.
Got it. So I have like a trillion questions. Let me ask maybe 2, maybe 1, maybe 7. We'll see what happens. First question. This seems like a really, really interesting use case for drift detection. And for instance, with that crash report, let's say in a factory floor that says, hey, you hit a person, you hit a box, that's going to be in plain text. And if you feed that into your system, it can then assess what new training data needs to be generated, retrain on the fly, and then redeploy. Have you guys thought about that angle?
Yeah, we want to make the switching costs of updating or putting in a new model like really low. And I was thinking about this a lot when we were working on this robot, because we were using an OAK-D, this smart camera by Luxonis, and it has this vectorized compute on it, a VPU. It's made by Intel, and so you're able to flash like MobileNet V2, kind of like maybe 5 megabyte sized model files on there, like 10 at a time. So you can build like some pretty sophisticated perception pipelines just with where that's at. But depending on what context the robot's in, you might not be as interested in detecting and tracking every person in the field of view, but maybe there's some other object of interest that you want to be monitoring. And so being able to make the training of these models really fast, really cheap, and make it possible so that this agent could, depending on the context, pull those models down. And I think even as we're thinking more about like open set, open vocabulary detections that the latest generation of models are capable of, like there's going to be that speed accuracy trade-off, and there's going to be the need to distribute the work onto the edge if possible. So, in this robot that we were working on, you might have like a powerful Xavier or something like this with a GPU, and it's capable of like a lot of computation, but still you have like 8 cameras on there, technically like 12 cameras. They're like stereo cameras with a central camera. So you would have all these camera feeds, and you can't really deal with that without pushing more of the models closer to the source of capture. And so there's going to be a need for these small, efficient, lightweight models to be deployed there, and probably a need for switching depending on the context. And you could imagine like the bigger LLM kind of controller living on that Xavier. And this would be like a way that probably people are trying to design these systems currently with what's available. So we want to really explore like data efficient, parameter efficient, and really fast kind of model training and updates, because we think that that's a good strategy for dealing with some of the context switching that you would expect when you're putting a robot in the wild.
Cool. Second question. It seems like you guys are still in sort of this exploratory phase where you're figuring out best practices, trying to see where your market niche could be. Ben and Terry, a question for both of you. It seems like with this text input to inform data generation, to inform retraining, to inform new model deployment, if that's generally the pipeline you guys are building, I'd be curious what area or what industry you would target first. And I was thinking about it, the criteria you can sort of think of as, all right, it needs text feedback. It probably needs to be low stakes and it probably needs to be high volume. So an example of not that would be military applications. Like, oops, we just blew up a family. That happens once every month. That's probably not the best industry to start out in. You want it to be a bit more robust. Likewise with factories, maybe that's a little bit too high stakes. You'd probably have volume, but if you knock over an entire cart of semiconductors, that's probably not ideal, and that would cost a lot of money. So what is the ideal entry point for this tool in terms of an industry?
Well, but before I answer that, I'll even say that there's another part of the pipeline too, like with multimodal models. It's a lot of them are getting specialized and adapted using pipelines with expert models. And so you could imagine it's text to data to model to then a pipeline for more data for like multimodal model or something like this. So you can, there's like so many ways that the data and the models are kind of like feeding into each other. But I totally agree. Like some application areas are not where we want to be. Like, I would not recommend to somebody to use a generated data set to try to make like the very best person detector or something like this. Like somebody who's really working with very expensive, large ground truth labeled data sets, less likely to lead to a robot that ran into something that didn't look like a person. Things that are lower stakes would probably be like these pipelines that feed into other models. So that's an area that I'm interested in as we're seeing multimodal models kind of mature and become more efficient. But I think that an area that I could imagine too is like wrangling data in a data lake. Like maybe you have millions of images in S3 somewhere, and you really just need to find all the instances that have blank in it. And so the cost of specializing one of these models and the cost of running it on those images is probably a better trade-off to make than throwing like bigger generalist model at the task. I would rather make a custom ladder detector to throw at my corpus of images and just map that model to a column of image file paths than to feed each of those, rate limited, of course, to GPT-4v. So there's like different areas in the cloud or in model creation. There's probably some areas where you can make a really good detector. And so if you have a situation where you just need to detect a handful of objects, say like aerial photography or something like this, these techniques can be used to help with that. But then there's other vision tasks where the I guess the information that you need to identify, it's subtle. It's like maybe like you're thinking of something like finding defects in parts at a factory or something. It might just be like a subtle scratch. We don't yet have a pipeline or a method for producing models that can help flag like those kinds of like fine-grained defects. Maybe when we get to like generating a 3D asset or something like this, then we'll be closer to being able to like synthesize that kind of data too. But yeah, I would say that this is probably most beneficial for people who are earlier in their process of creating model pipelines. And at some point, you could imagine an organization gets to the point where having a team and really getting into investing in that pipeline is valuable for them. But for a lot of organizations, it may be something kind of simpler, like the kind of problems where you could pay a consultant for a quick project, but it's not like, a core feature or something that you're highly invested in, like recommender systems, right? Like that's going to be a difficult problem to get to the point where you could just fully automate it.
Yeah. Could not agree more. Yeah. As far as industries, I can't think of a specific industry where it would be like, oh, you could only, like, this would only succeed at first in this sort of industry. This seems so broad and applicable to so many different industries and jobs that I've interacted with. To give context on that, let's say your initial idea that you came up with, that you're mentioning about a physical project, you're like, oh, we're going to use an image classifier to detect when this plant needs water. Something like that does not require human expertise per se. Like in an ideal world at a farm, like large scale agriculture, you shouldn't have a person going around looking at stuff like that. What's the solution right now is to deploy cameras on crops. And then some human still has to go and look at those and say, I got to go out to plot 43B and check on on that corn crop. But when they get over there, it's not like they're doing a lot on a modern industrial scale farm. They're going up there and they're visually classifying what the problem is and then activating some automation to do something for that. Like, oh, time to turn the sprinklers on, or time to turn the sprinklers on less because it's too much water, or some sort of soil sample that needs to be taken and analyzed for potassium content. Like what's going on, or are there bugs or something eating the crop? All of that stuff I don't think humans enjoy doing at industrial scale. So an application where you can monitor something like that autonomously at the edge, but then adapt to changing conditions. Like, oh, we have this massive storm system that's coming through. Do I need to swap out to determine what the effect of this is with a slightly different model that's detecting damage to crop rather than, moisture to crop? Something like that resonates with me a lot. And then industries like advertising and marketing, I think stuff like this is incredibly useful, where you can rapidly update to latent factors that are affecting a model that you're not aware of, or you haven't been able to collect the data because the data didn't exist until yesterday. And then a rapid retraining, redeployment, and then reuse of generated assets. I think a simplified pipeline for that adapts to a fast changing environment would be a very big game changer. I mean, I hope you guys solve it, like really solve this and make it so that you all of a sudden are in this position where you're like, man, we got to hire 100 people. Like we can't deal with this.
No, I hope so, but I guess like to add to that too, right? Like a lot of problems, don't need machine learning, and you have to understand if the relative cost is there low enough to justify that type of solution. And so while we're over here geeking on the drought stress detection models and things like that, like to what extent can you change the irrigation? Can you, right, or does the plant need it? Nature does pretty well with like the environmental conditions that plants have evolved in for all this time. So it's like, where is it valuable? And I think a lot about like the value would be especially for people who want to make a new product and they want to be able to use AI cheaply, but they don't have all the expertise that they need to like get the data wrangling, the pipelines, the monitoring, the model updates, that whole kind of the whole ML life cycle. So we would like to be able to just keep kind of expanding on what we can do with image and text data, and building pipelines that help people get quicker to an application. There's like finitely many reference applications, reference patterns that people practically care about now. So how much can we just accelerate their access to those kinds of pipelines? I used to think earlier in my career, like everybody's going to want to be a machine learning engineer. But, after working in a few different orgs, I understand like a lot of people are never going to like get into like, data mining and trying to find these patterns and things like that. So like what tools are possible to accelerate that for orgs so that they can test an idea, get to market, find out if it's worth investing in like the team and everything else. Because a lot of times it's a little bit backwards now. An organization says, I want to do AI. I need to hire an AI expert. And then they've went so far into this investment. And I've seen it, in my own experience, where it's like, did this company really need a machine learning specialist, or did they need like a consultant to work for a couple of months? Yeah.
Yeah. And something that I've seen that's really blown my mind with the ML field in general is that we're now interacting with an entire new generation of people that are interacting with AI, and they don't come from the background where they've ever had to go through the process of generating a feature set, training a model, testing that model, going through 173 iterations of training until they got it kind of right, and then send it out for review by experts, and then go back to the drawing board, train it up 30 more times. That whole life cycle, that whole process of what it is to deploy production ML and then write a full code base around that. Even if you're experienced and you're solving a sizable enough problem at a company, that's months of work to get something that's a major project out there. Like, do you need a REST API around this? Okay, we have to think about deployment. What's the scalability of this? How many requests are coming in? Oh, 6,000 a minute. Okay, we need Kubernetes. Now we need to think about that aspect of this. But now people with interacting with somebody else's infrastructure, you can interact with OpenAI SDK and ask it whatever you want it. You can prompt it with something complicated to control how it is, doing it. Or if you want to go with something more specialized and you're using Hugging Face Transformers SDK, and you're taking a foundation model, you're fine tuning it, or using something like PEFT to do, updated weights on top of that. You're not doing that life cycle of ML, of like getting that to the point where it's ready for production. So what's amazing to me is now people are expecting behavior with Gen AI interactions that are orders of magnitude faster. Like nobody cares. They're like, yeah, I just want to test out 400 different prompts and see which one performs the best. Those 400 prompts, they can get an answer to which one of these solves their problem in 3 days. And it just blows my mind, this revolution that's happening right now. And I think that's that distills down like what you guys are trying to work on is how do we get that same sort of behavior and speed and rigor, but applied to some of these more traditional ML things?
Yeah, I would say, a lot of admiration for what OpenAI has been able to do with simplifying access to like very high quality models. You can go on their store and like whip up something that's using like RAG in the background and, test an idea like faster than ever, right? Like you used to, as you said, have all this overhead just to get your model into somebody else's hands to try it out. And now, probably in 30 minutes, you could test a new idea through something like their store. And if that's good enough, justify like, okay, now I'm going to write the code base that uses their API. I'm not yet at the scale where I'm thinking about owning the models and the infrastructure. But eventually, the more invested into the problem you get, the more you're going to want to control those costs. You're not going to want to cut $1 million check to OpenAI when you have enough users. And so, that's where I think the pain points are now, right? Is like, I want to have OpenAI level LLM inference, but I want to self-host or do something that's more cost effective. Like, how could we help people to adapt the models to their use case, to help them to self-host or do something on-prem, or things that are more like real-time and at the edge, in these other areas where you won't find a solution from a product like OpenAI yet.
Right.
Cool. So I think this might be the best breaking point for the next like 6 hours. So I'm going to take advantage, and I know we're at time and we have busy lives, so we should return to those. But would love to keep talking. So in summary, we talked a little bit about Tubi at the beginning and recommendation engines. Specifically, they're often subject matter driven and simpler than you might think. Throwing everything into a deep learning model, unfortunately, once again, doesn't solve it. And evaluating these models with A/B tests is, again, really challenging because of the user interactions and the interactions between even concurrent experiments. So it's important to think about what exactly your North Star metric is showing and what exactly you're testing. Image generation almost always leverages transfer learning, and there's often a big backbone created by one of the big tech companies, and you want to sort of fine tune or leverage that to your use case. And that's exactly what Terry is doing at Remix. They're sort of trying to remove a human in the loop and instead use smart LLMs and generative models to inform how smaller models, specifically on edge devices, should be retrained. And they're sort of still in the exploratory phase, but yeah, I'm very excited to see how you guys grow over the next few years. And again, if you solve this, as Ben mentioned, hundreds of people will be working for you in no time.
Oh.
So Terry, if people want to learn more about you, your work, or Remix, where should they go?
Well, check out Remix with a y.ai, and check us out. I'm Terry Rodriguez. Find me on LinkedIn, or you could see our Twitter, Smells Like ML. So we're around.
Awesome. Cool. Well, this was a lot of fun. Until next time, it's been Michael Burke and my co-host,
Ben Wilson.
and have a good day, everyone.
We'll see you next time.